Corals can reproduce both sexually and asexually. In sexual reproduction, corals can either be broadcast spawners or brooders. In broadcast spawning corals, the eggs are fertilized outside of the coral polyp, while brooding corals are fertilized inside the polyp. Most broadcast spawning corals are hermaphrodites, meaning they produce egg and sperm bundles, which are released into the water column. When they break apart, they become fertilized with bundles from neighboring coral colonies. Corals have 1 or 2 mass spawning events each year. In Indonesia, this typically happens 4 or 5 days after the full moon in November, or sometimes in spring, depending where you are in the country. The spawning is triggered by a slow increase of water temperature over a few months, and this usually happens just before the water temperature is about to go down. After sunset, corals start to release the sperm and egg bundles in the water column, where they break apart and mix with egg and sperm from other colonies of the same species. The fertilized gametes then become small planula larvae covered in tiny cilia. These larvae have limited mobility, although they can swim around the water column, searching for a suitable habitat. The larvae are capable of settling up to 3 or 4 weeks after a spawning event, giving them time to drift with ocean currents and colonize new reefs. The settlement process for brooding corals is the same. However, the difference is that brooding corals are either male or female. The female coral keep the eggs inside the polyp, and during a spawning event, the male corals release sperm, which is taken up by the female. The eggs are then fertilized inside the polyp, and a planula larva is released.
Since coral spawning events happen only once, sometimes twice per year, corals have adapted to survival by asexual reproduction. Each coral polyp is an identical clone of the original primary polyp, and coral polyps grow by dividing and budding from the original polyp.
Some of these species inhabit very competitive environments, such as shallow, bright water, and have evolved to concentrate their expansion strategies to asexual reproduction. When a big storm hits, they break easily and quickly attach to new substrate.
Because of this strategy, we have the ability to harvest corals from mature coral colonies and transplant them in suitable reef habitats. Corals have the ability to regrow, even when the skeleton is broken.
Remember in part 1, when we talked about coral polyps and skeleton? The polyp is the only living part of the coral, and it builds up the skeleton layer by layer. So the inside of the skeleton is just old calcium carbonate deposits, and the only living part of the coral is the polyp and the outer layer of tissue. Corals always start growing from the base. New coral fragments start encrusting tissue and skeleton around the base within 1 or 2 weeks. They do this to build a strong foundation to hold up the rest of the coral colony. Encrusting and plating species of coral start encrusting around the fragment edges, just as primary polyps start developing new polyps around the perimeter of the polyp base. Branching and plating corals can grow a few centimeters per month. Their skeleton is usually very porous and light. Massive, dense corals grow only a few centimeters per year. All corals grow faster when they are small and slow down when they are mature. And they use some of this energy for reproduction instead of growth.